Welcome back to the hyperbolic heaping chamber. We're back once again. The heaps are expanding. Heaps of brain, heaps of mass, Heaplon Musk. Yeah, that's where we currently are at. We're mastering the heaps. One could say that we might have invented the heap. So I'm thinking it might be some Attack on Titan action. I might have in the future built a time machine which takes me into the past where I actually develop the heap and then I go back to the future, to the present. But right now we're actually in our worst timeline because we're in the worst timeline because we actually have to grind up until we make the time machine. So it's actually kind of awful. But until then, this is kind of where we are at. Yeah, yesterday I was kind of low on some brain sauce. I was doing some thinking, and I did actually answer. I did do the comments yesterday, but I didn't. I just wasn't feeling up to it, so I cut the part out, and then I just uploaded us doing LeetCode. But I definitely realized there's definitely some perfectionist issues here. I didn't feel like the take was good enough, so I deleted it. Even though I usually just say random stuff anyway. But yeah, that being the case, the hyperbolic heaping chamber is also about deconstructing heaps of trouble. So one of those troubles seems to be perfectionism. So we're gonna have to work on that. So I just bought a perfectionist workbook, and we're gonna see if it can undo what has been done. So that's gonna be the next grind. So we're gonna do that. We'll see how it goes though. But that being the case, we need to work on the comments we didn't look at yesterday. So we're gonna look at those comments as well as a new comment I think we have, but I'm not exactly certain. But yes, so we had a comment yesterday that said happy 200, and I said, yeah, happy 200, feel strong, man. Hopefully 200 more to go, but we shall see. I surmise in 200 days we'll have finished all the easies, no doubt, because we are actually exponentially increasing in speed. We also have to take some time to learn some new knowledge though. But yeah, so things are going well there. So feel strong. Shout out Cold de Reuter. Hope to see you in the Discord. Hope to see you in the Discord. And then we have a comment from OP Stealth saying, "Why do you do this?" And using the Explore cards this way. This was on the LeetCode Explore cards are torture. Yeah. Why do we do this? I'm not certain. We do this because our brain does not work. And I think for some reason I have to watch the videos on 0.5 speed to retain any semblance of information. So unfortunately it might be the worst thing that ever happened to us. But yeah, that video is actually torture. So hopefully in the future things won't be that way. But I remember reading from a book, or I remember it's coming to me from some quote, but I think we're talking about chess here, but another way, hopefully the chess analogy applies to LeetCode as well, but they do say another way to tell if another predictor of grandmaster status is ability to remember chess patterns. So hopefully as we remember more patterns, as we accumulate more patterns, we will be able to ingest even newer patterns and so on and so forth. So hopefully we should be able to see a piece of code and instantly remember it. And we've already kind of experienced this before, because for example, sometimes we'll be not all code, but for example, when I first started LeetCode, it was hard to remember or hard to understand a piece of code, right? Or a solution, and then later on we're working on a problem where it might use a DFS or BFS or like a disjoint set or something as part of the problem, and I'd be like, wait, what does this code have to do with it, or what's going on here? But as we get comfortable with the patterns, it's like, oh, the solution, it used to take me a paragraph to describe some solutions. Now some solutions can be described just by the name of the pattern. You can already intuit the solution based on the pattern. So we're not there yet with every single problem, but especially with some of the easier problems and some of the simpler graph-based problems, I feel like when I first started, I didn't really understand, like, oh, how does just knowing the category of the problem solve the problem? But now we're at the point where if we see the categories of the solution, we already know the problem. Not in all cases, just easies, mediums, hards, impossible. But hopefully we get there. So that being the case, yeah, That's the goal, so that's why we spend so much time on them. And then we have a comment from Wilderness. Familiarity and repetition guarantee a baseline of competence. It explains how T1 got all 5 roles challenger, despite an uninspired process of improvement, sitting in chair, 14 hours spamming games and raging. With enough ish, something will stick on the wall. I kind of half agree, or 80% agree. T1 is actually a different breed. His process is actually pretty impressive. I remember in I forgot what book it is. It's probably a book by Malcolm Gladwell or Ultra Learning, or just in general other performance books. I think they always mention the key to there's something called the O. Apparently, there's something called the OK plateau, where people get to a point where they think they're good enough, or they feel that they're good enough, and then they stop progressing. So a lot of things are like this. I know for me, one thing that's like this is driving. I'm just an okay driver. I never got any better. But then they say that the fastest way to improve is to stay out of. Let me explain it. The OK zone, the OK plateau is typically where you can go on autopilot. So I would play League where I would drive and I'm on autopilot. I'm not really getting any better because I don't really have to think. I'm just kind of employing this decision tree that, while inefficient or not that impressive, is just being employed. And it's not getting any better. I'm not modifying it at all. But they say that the best way to improve is to stay out of autopilot. And I remember watching T1 streams. I don't know if he's intuited this on I mean, he's probably intuited this naturally because he's already so good at the game. But I remember watching him stream one time, and he was like, I'm on. I think he literally said, I gotta stop playing on autopilot. And it's like he already knew that he had to be solving the game every game, otherwise you just stay where you are. And it's just very interesting. After he said that, I started to look at his streams differently, because sometimes he'll play the first 2 or 3 games actually thinking, and then he gets tired of thinking, and then he just kind of plays with the model that he already has, which is already really good, so he still wins games anyway. But it's just really interesting. I found the same thing with LeetCode. Nowhere near T1's level, even if we bring it down to LeetCode, but even at 200 or so problems done, or almost 300, I'll be sitting there and I'm like, oh man, I have no idea. I'll solve 5 or 6 or 2 or 3 problems, and I'm like, oh, we're on a roll, and then I'll just stop thinking about the problem and I'm just gonna solve it without actually thinking about it. In some cases, this is fine because I can blow through problems, but in other cases, it literally takes longer because I just won't sit down and think, which is really unfortunate. And it's kind of what happened with the problem yesterday. So we're kind of working on a problem, and at one point I just kind of got tired of thinking and I just started just throwing myself at the problem, but we're not actually solving it. That's why I said we'll probably get it tomorrow or the day after, because when I start with a new day, I have more brain juice, and then we can actually sit there and think about the problem. So yeah, I don't know. I would just kind of a really long rant there, but it's just to say his process. I don't know. I feel like his process is really impressive. It's a simple process. Stay out of autopilot, but it works so well, and it's like a cheat code. And I had to tie it all back together with driving. I'm still a trash driver, but I realized you kind of had to stay out of autopilot. And to stay out of autopilot, I usually drive at like 60 miles per hour, but in certain cases I would drive at 70 or 75. Where applicable in your local jurisdiction. And that actually made me better. And it took me, I don't know why it took me so long to realize that I was pretty much cheeks. I'm still cheeks at driving, but I was really cheeks at driving because I would usually drive at 45 or 50 like grandpa speeds. And I couldn't understand why I wasn't getting better. And then I started driving at 60 and I was like, oh, for some reason driving at 45 is remedial now. And then I started driving at 75. I was like, oh, for some reason driving at 60 is remedial now. And it's just a really interesting process. Skiena is the author of the other part of the comment. What is Skiena? Skiena is the author of the Algorithm Design Manual, legendary book, legendary author, legendary visionary, as well as computer scientist and algorist. But that is the holy text of the hyperbolic coding chamber. We'll be going around later on in Discord checking to see if everyone has a copy. If you don't, there's going to be some serious repercussions. And I think, oh, we have one more comment actually. How do we miss this? This person says, I am nowhere near your coding level. I promise you are, but I am mostly afraid of DS and Algo. And all the time I see these competitive programs, it makes me think of how bad I am at coding. But I know that if I keep at it, eventually I'm going to be decent. Feels strong, man. Wish I started coding with C++ and not Python. I don't know why, but people seem to demean the language for its simplicity. Yeah, a lot of people seem to rag on Python. I don't really understand. A lot of people also rag on JavaScript and TypeScript, even though I'm not exactly certain why that happens. I know why it happens for JavaScript because the tooling is kind of troublesome, but I don't know. I really like the language, and that's why I forcefully use it on LeetCode, even though it's probably not the best idea. But nowhere near. I promise that you are. I haven't done a lot of problems. I'm still afraid of DS and Algo as well. So much so that it took me forever to get around to just learning the heap. Even though we found ways to sneak past it, we've been avoiding it. But we just got to jump into it. But I think if we both keep at it, we will get where we need to go eventually. Feels strong, man. I'll see you at the top, brother. Feels strong, man. But yeah, if this is something interesting, you should definitely join the hyperbolic coding chamber. I'm getting tutored by the people in the Discord. So I think there. Oops, my tab just popped up. I think there's room for all of us. And also, I only started this like 200 days ago, and my brain is not functional. So I feel like if anyone else with a functioning brain spent a similar time, they would be miles ahead. And I think that is pretty satisfying. I feel like that's pretty rewarding. So I feel like you should jump in there, brother. And I'll see you at the LeetCode World Cup tournament in 2025. If you are not there, I will be sad. But yeah, we just gotta keep on working. I remember when we got to day 200, I received the message from the grandmasters. They're telling me you gotta stop. You can't keep doing so much LeetCode. And people from my account, they tried to ban my LeetCode account. It was pretty crazy. So the grandmasters are shaking their boots. They don't want us to try LeetCode. And Alfred, I think they don't want you to start LeetCode either. So I think you got to get in there, and we'll see each other at the top. Bakugo X Midoriya type beat, and I think they won't be able to stop us. So feel strong, man. That being the case, we'll see Alfred in the Discord, and additionally, we have a problem that we're stuck on that we're probably going to jump into. It's still the heap problem. This is the problem where we're still wasting time, and we need to do better. So this is what we're going to try and do. It's working, but it's not working. So we're going to slowly work through it today and see what happens. That being the case, we're going to start our timer. It's going to be exactly 1 hour. And so we have a heap implementation that is troublesome, to say the least. And at the same time, it works for simple data sets. But at the same time, when we have a data set that is already sorted in descending order, we ended up in a loop. To fix that loop, we modified some of the code, but now the output array is nonsense. So you have 2, 3, 4, 5, 6, 7. And wait, maybe we did fix it, and we just have to change. We have to remove this equal sign. No way. Let me check if there's any more consoles. Doesn't seem to be. I'd be surprised if this works. I'm gonna bring back that last one to see heap, to print heap.nums to see what we're working with exactly. Right, it actually does seem like there are some cases when we actually do want to slide this to the end. So what we'll do, I think, at the end here, we'll check if this dot size equals 0, right, and this dot nums dot length is greater than or equal to 2, and this dot nums sub this dot size, because we want this to be an ascending order, this dot nums of this dot size is greater than this dot nums of this dot size plus 1, then we pretty much want to do the last bit here and move it to the end. Oh, I guess we can just add more to the test cases. For some reason, 4 is never sorted in the correct spot. I just wait. Unclear why some of these cases are giving us trouble. But once we add a 5, the whole thing falls apart. We make this. I think we're just guessing. Oh, we should just do what we said earlier. Oh, I keep fighting it. We just have to go through this. The code you wrote is spaghetti code. This is miserable. Maybe you need to be going upwards. left child is less than the right. Seven would swap with 3. In fact, we'll just make this 2. 7 would swap with 3. Like this. Then it feels like the next part just has more to do with swapping our literal parent. So I feel like this should be an if statement. We did something fine, and now we need to keep swapping upwards. Well, the question is, which index do we use now? Index should stay the same, so it shouldn't become smallest index. Because these were swapping the values in the array. We swapped the values in the array, which means index is now pointing at the smallest index, which is 2. If we get the parent for that value, then we first need to check that the parent exists. And this dot nums sub this dot parent sub index is greater than this dot num sub index. I'm sure there's a smaller implementation for this, but we'll change it afterwards. Now, if this is the case, then we need to swap we'll save index because we're going to replace it with the value of its parent. And then we'll say this dot nums, so this dot parents of index gets the value of temp, and then index then we can make one more function. So I think we would just want to say math.floor of index divided by 2. Let's check if that makes sense. So if we look at this one like this, we want to get the parent of 5. That would be 0, 1, 2, 3. 3 over 2 is 1.5 floored is index 1. Okay, let's say we want to get 7's parent. 0, 1, 2, 3. 0, 1, 2, 3, 4. 4 over 2 gives you index 2. 0, 1, 2. So it looks like the answer changes based on whether or not you're odd. So we'll just change the whole thing and we'll say index mod 2 equals 0, which means you're even. We'll just say you can return index over 2. Otherwise, say math.floor of index over 2 minus 1. So can we get 9's parent? So it'd be 0, 1, 2, index 2 divided, it's odd, so 0, 1, 2, index 2 divided by 2 would give you index 1. 0, 1. But you definitely can't get your parent this way. Zero, 1, 2, 3 over 2 would give you 1.5 floored. Could be 1. That would give you 2, which is correct. And then if we did this one, we get 0, 1, 2, 3, 4 over 2 would give you index 2, and we'd subtract 1 to get 2. Or if we try to do the same thing for 9, which is odd, we do 3 over 2, we get 1.5 floored is index 1. 0, 1. Three, 2, 9, 5, 7. Wait a second. Can't you just reverse it? If you can get your left child index times 2 plus 1, couldn't you get your right child by doing index divided by 2 minus 1? So if we had 2 here, 2 divided by 2 would give you 1, minus 1 give you 0. And if we had 3 here, we'd have actually no, you have index 0, 1 here. 1 divided by 2 is 0.54, it is index 0. Maybe we should be sealing it. So we'll do here index 2. 2 divided by 2 gives you 1. 0, 1. I don't get it. How can we go backwards? How can we go forwards with left and right parent index in left and getting the left right child where we can't go backwards? I don't understand. I don't understand. How is it that we can go forwards but we can't go backwards? Maybe it's because the forward function asks how many future nodes we'll have. What if we're doing it in the wrong order? So for index 3, we have index 0, 1, 2. If we subtract 2 first and then divide by 2, we get index 0, which is correct. We have index 0, 1 here. If we subtract 1 first and then divide by 2, we get index 0. Now for index 5, we have 0, 1, 2, 3. If we subtract 2 first, 0, 1, 2, 3, we'll get index 1. Divide that by 2, we get 0.5. If we seal it, we get the correct parent. Now if we take 7, 0, 1, 2, 3, 4, divide by 2, we index 2, 0, 1, 2, wait, no. We have 0, 1, 2, 3, 4. We subtract by 2 first, we get 2. Divide by 2, we get 1. So I think we can go forwards and backwards. If it's even, so if we have something like 5, right, we're going to say 0, 1, 2, 3, divide, minus 1, 0, 1, 2, 3. Minus 1 gives us 2, divided by 2 gives you 1. Here we say if we have math.seal, index minus 2 divided by 2 is something like 7 here. 0, 1, 2, 0, 1, 2, 3, 4, or 0, 1, 2, 3. Wait, 5 is, what is going on? 0, 0, 1, 2, 3. Subtract 1, we get index 2. We divided by 2, we get index 1. So if we have index 0, 1, get our parent, we would subtract by 1 and divide by 2. Now if it's like 9 here, 0, 1, 2, we would subtract by 2 to give you like 0 and divide by 2, which would also give you 0. Alright, let's just try the input that's giving us trouble. 3, 2, 1, 5, 4. We call a heap of 5. Size is equal to 5 or 4. I is equal to this dot size, which is 4. I is equal to this dot size, which is greater than 0. I is equal to this dot size, which is 4. I is greater than or equal to 0. So we're going to check this dot left index. This dot left index will give us infinity or -1. think we need assistance because I don't get it. Or I guess we could rewatch the video. I see, we're going the wrong direction. Right, we're going the wrong direction, so we need to be going downwards. This whole thing about this parent stuff doesn't make any sense at all. We can cut this whole part about this while loop out. The index should actually become smallest index. So you're on the right track earlier, it's just something about this is making this go infinitely. Swapping 3 with 2. What are we actually getting for this? I'm making this take so much longer. I should just read and I should just run the code and follow it in my mind, but I'm refusing. This is the problem. Once you get to 5 here, it should swap with its child because 5 is greater than 4. But it doesn't. Oh my god, I think I just figured it out. Then if I add index equals smallest index, I see now. But I should just use index everywhere. And I think that was the problem. Wait, why isn't the tree changing? on 6, on 5. When we get to 5, we should see that we have a child that we're greater than, but we're not. On 5. I think it's the children aren't changing, but for some reason the children aren't changing. Three is greater than 2 or 1. So here's where we should stop. Then we start again, saying starting at node 4. So I think we can remove this equal sign. I think we should be good. My issue is I don't understand how we're getting 4 is greater than 1 or undefined. I see, but if we say this dot size, then it doesn't run often enough. That last try, Yeah, we're just gonna have to look at the solution tomorrow, or the the implementation, because we are